Howdy PreCal, it's Miss Kosh, and we are working through the application problems. So I found some notes that I had from a few years ago, and I've made a worksheet, a beautiful page to go along with it, but I want to highlight a few things that video didn't say. So I'm going to post that video first and then this video second. So hopefully you already watched that. If you didn't, you need to. I think I talked through the interest rate formulas a little bit. I didn't give you details here highlighted in yellow. I think I jumped down to this part and talked about what makes it an exponential growth or decay. But if you want to fill that in, it's the amount, the initial amount, the rate, the growth or decay factor, and then the time. Sometimes we use a t, sometimes we use an x. So that's what's happening there. I think I talked about this one right here. And so then I just copied into my answer key the 3 problems straight from the video. I did go ahead and give you final answers. So if you want, anyway, here they are. Look and go back and watch that video if you don't understand what's happening. Okay, so the last one, this is new to this year because I just made this one up. It says, what is the rate of growth in the population of Coppell, Texas, if the population was basically 36,000 people in the year 2000, and it's about 42,000 people in the year 2020. Okay, so we'll notice that our time that has happened here, our t value is equal to 20, and this is a growth problem. So you can either use, we can use one of these 2 formulas, and it doesn't really matter. If you use this one, then when they ask for what's the rate of growth, you're going to have to figure out what the r value is anyway, but you can get there either way that you would like to. Okay, so what we have, our amount, and you know what, I'm going to use this amount in 2020, I'm just going to use it, is the amount in the year 2000 times that growth factor raised to the 20th power. Okay, so yes, okay, here we go. So the amount that we have here is this 42372. We started with this. I didn't really think through this problem, but I did Google it to see what was the population in Coppell. Okay, so now I'm going to need to divide both sides. I have 42372 divided by, oh, gross, is equal to a to the 20th. And now what my goal is to figure out what is a equal to. Okay, so I've got a to the 20th power, but I want a to the first power. So what I'm going to do is I'm going to raise both sides to the 1/20th power to see what that value would be approximately equal to. I'm going to I have my calculator off to the side. You can't see it, but believe me, it's there. I'm going to type in, hopefully type in correctly, 42372 is in the top, divided by 36567. This whole thing, oh, I didn't put a parentheses first, that helps, needs to get raised to the 1 over 20. Okay, and I found that a was approximately 1.007394. Oh, okay, here's my equal sign. And so this is 100. So what I found is I've found this a value right here, and so I can, notice it's bigger than 1, so it is a growth factor. So to find that r value, I can subtract away 1. So this becomes 0.007394, and if I want to make this a percent, I can move my decimal point 2 places. And so how much has it grown? We would say by 0.7394% over those 20 years. So I would say that that's not a ton, but anyway, it's growth. Okay. All right, hopefully that helps. The other 3 examples all required you to use logs. This one you didn't, because you weren't trying to solve for something in the exponent, you were trying to solve for that rate. So that's why I wanted to include this extra example. So I hope that was helpful. Good luck, go practice, let me know if you have questions.